equations of motion using graphical method. That means using graphs. So you have to derive equations of motion using graph. So say here, first we have to draw graph between velocity and time. Here I have taken velocity in this axis. Here this is O, we can take here time in this axis. Suppose graph is like this. We can take this is a initial velocity u, and here this is final velocity is v. Now we can give this name, this is A, this is B, and we can draw like this here perpendicular here, this point can be said C. Now I can draw one line over here, this can be given as D. So see here, first we can take slope of this graph. Here we can write BD is equal to this much BD. From here to here this is V, from here to here this is U. So we can write BD is equal to V minus U. This I have taken 0 time here, and this we can take as T. So we can write AD is equal to T minus 0, that is equal to T. So now we can write slope of VT graph is equal to BD upon AD. Here we can write BD upon AD is equal to V minus U upon T, which is equal to acceleration. We have done already, this thing is here. So now we have got slope from this graph, that is V minus U upon T is equal to A. Now we will write this equation in another form. So we can write here V minus U upon T is equal to A here. So we can write V minus U is equal to AT. So we can write V is equal to U plus AT. So see here, this is the relation between velocity, acceleration and time, but acceleration remains uniform, and this relation is known as first equation of motion. You can say first equation of motion, otherwise you say better relation between velocity, acceleration and time. So now this was the first equation, you can refer as first equation. Now we can derive another relation, we can find distance from here. So now we will derive formula for the distance or displacement. So now we can calculate distance or displacement from this graph. So we can calculate here distance travelled in time t is S is equal to, I have told already, to calculate distance we have calculated the area between velocity time graph and time axis. It means this whole area. So we can write here area of OABC. So area of OABC. This we can divide area into two parts. So one is rectangle, one is triangle. So we can write here S is equal to, that is the distance or displacement you can say. Here area of OADC rectangle plus area of triangle ABD. Here we can write OA into OC plus this area of rectangle, area of OABD, triangle ABD, we can write half into AD into BD, base into height simply. So now put the value of OA, OA is U, OC is equal to T, so we can write into T plus half AD is again equal to OC, that is into T, BD already we have calculated. So, BD we can write here, that is equal to V minus U. So, we can write V minus U over here. Now, see here, we have done V minus U is equal to 80. So, we can write here S is equal to ut plus half t into 80. So, it is S is equal to ut plus half 80 square. This is the relation between displacement, initial velocity, time and acceleration. So, basically velocity, displacement and time. Now, similarly we can calculate relation between velocity and displacement, that means without time, there is no time. For that we can take again from here. So, I will use the same graph which we have used for the other two equations. This equation actually referred as second equation of motion. So, now for the third one we can write again area of trapezium OABC is equal to displacement. So, here we can write area of trapezium, that is equal to displacement, we can represent it by S. So, we can write S is equal to, what is the area of trapezium? Sum of the two parallel sides, it means OA plus, we can write BC, these are the two parallel sides, into height is AD divided by 2. This is area of trapezium. Now, put the value of all these. S is equal to OA, we can write U plus BC, from here to here we can write V, AD is time divided by 2. Now, I can take this step to this side here, we can write S is equal to U plus V by 2 into T, we can write V minus U upon A, using V minus U is equal to 80. So, we can write T is equal to V minus U by A. So, using this relation we can replace the value of T. Now, we will solve this. S is equal to, we can write V square minus U square upon 2A. So, we can write here V square minus U square is equal to 2A, 2AS, S is multiplied. So, V square is equal to U square plus 2AS. So, this is the relation between velocity and displacement and acceleration without time. This equation we can call as the third equation, but not necessary to name equation 1, 2 and 3. We have to actually learn by this the relation between velocity, acceleration and time, relation between displacement, velocity and time, and relation between velocity, acceleration and displacement, no time.